Hello, I'm Evan from MacDonald. Thanks for coming. I'm going to talk about asset inspection optimization. If you work in infrastructure, then I hope that you can come away with an idea of how applying some of these data science techniques could help you. And I guess more generally, I hope, as with many of the other talks today, I hope you come away with an idea of how data science can help in geospatial problems. So I'm going to present here a project that I did with the City of Edinburgh Council. I'm talking about asset inspections. They have a big data set of bridges that they kindly provided for this. So asset inspections, why are they important? I guess one point is bridges are really crucial. They're often at points of low connectivity on the transport network. And as such, you need to make sure that you have no downtime. And that's ignoring the obvious that a critical failure of a big asset like this could have harrowing consequences. But beyond that, I think there are wider applications to the work here. It doesn't have to be about inspection. It doesn't have to be about bridges. I think it works for any kind of geospatially distributed task management. So why optimize? What results can we expect? So in this project, we managed to get savings of about 30% across the board. We were able to ensure that the inspectors had to spend about 35% less days going and inspecting their assets. And we got about a 31% reduction in emissions, labor costs of driving, and costs of fuel. So providing this work package management and telling people what days to inspect their assets on is a massively computationally expensive task. But we managed to cope with this by splitting it into two sections. First, we look at where we want to be, our goals. We find the best possible spatial work packages, and we say, this is our idea, this is where we need to get to. But then, if we presented this to the engineers, they'd say, so what, right? It actually costs a lot of money to transition from one schedule to another. So we need to provide a transition plan, otherwise our business case falls out underneath us. So the clustering, what do we do for this? First, you have to think about your distance function. In this case, we used open source routing machine powered by OpenStreetMap, as I imagine many of the presentations today are. It was a really powerful tool. It was able to get us road distance travel times, which is how the inspectors are going to travel, so it makes a lot of sense. There's also an added hidden bonus here, where when we're talking about these big assets on the highway, sometimes you would have to close a road to inspect them. So our distance function aligning with that road network is really useful because it means that we might be able to get multiple inspections done with one road closure. There's an added issue here, though, where we can provide all these clusterings, say it would be great if you inspected all these bridges on this day, but then it doesn't help if that day is got to be a 48-hour workday. We need to limit our cluster size to be respectful of the inspectors' workdays. We do this by looking at the condition of the bridges and also how big they are. The engineers joke that the data set they gave us contains everything from 2 sticks over a stream to 4 spans over a motorway and weights them all with equal importance. So it's very important to us to make sure we spend the right amount of time on the right kinds of bridges. You can see this in the image here. If you look at the assets over that river on the left, they've got a much bigger cluster. There's a few more together because you can get away with inspecting more than one day. But there's plenty of size 1 clusters here where inspecting these bridges would take a whole day in themselves. So how do we do this clustering? We actually have a bespoke machine learning algorithm to do this. It's based on existing work using kind of hierarchical or agglomerative clustering. But we built this kind of workday length and this road network alignment into the algorithm. This is really interesting, I think. I really like this as a key takeaway, is we have these business interests and we encode them in our algorithm as a key principle. This means that we don't have to mangle our input data or do loads of post-processing for legal compliance or getting the results we want. The algorithm is actually trying to solve exactly the same problem we are because we gave it the cost functions we're considering. So yeah, I think that's really cool. It's also pretty dynamic because there's pairwise input distance. You can use whatever you want for that. Maybe that is kind of mangling the input a little bit, but the notion of the distance between 2 assets is quite flexible. So yeah, we got our clustering, and then this is all well and good, but we need to provide a transition plan for this to have any value to the client. So we need a pragmatic approach to shift from the current state of their inspections to the state that we suggest they should be in. We actually find that the cost of just changing schedule overnight is, in the realm of tens of thousands of pounds. But with a little bit of sleight of hand and an 8-year transition plan, we managed to reduce that down to £10, which is really cool. You don't often get to pay an infrastructure bill with notes out of your pocket, right? So yeah, I was pretty proud of that. But I was a little worried because I was like, well, this 8-year transition plan, that's going to be a hard sell, right? The client's going to be like, well, we have to wait 8 years for our results. And it actually took me alarmingly late in the project to plot this graph. And I was like, oh, maybe I'm okay. So we see that our savings, they jump up to above 30% in the first 2 years. So how do we do this transition? How's our algorithm work? It's sneaky. We actually just reuse the clustering algorithm. If we think about it, our clustering algorithm is about finding these work packages in space and grouping them together. And then deciding what date to inspect these assets on is actually just about finding the groupings in space to align these assets. So I like it, the sci-fi and nerd in me is very happy to say I've got a space-time clustering algorithm, which is really just saying go and inspect this bunch of bridges on this day, but space-time clustering sounds cooler. Yeah, I'm pretty proud of that one. And yeah, we codified this with there's a lengthy document detailing the legal requirements for inspecting these bridges. I read that document, copied the cost function, and put it in my algorithm. It works straight out of the box. It's this really nice kind of business interests, machine learning aligning. So yeah, how do we show this to the client? Maybe in slight contention with Kato here. We have in Mott MacDonald our own Mott platform for geospatial. The benefits of having a platform like this is that we get polished front end. I, as a data scientist, don't have to worry about, how React works or anything like that. We also get to do user management. So if the client says, oh, can we add this person who's just come to our project? We just need their email address. It's nice and easy. And there's a bunch of other composable solutions that we can tie together here. So we have the maps, we have this inspection scheduling. Maybe we need to worry about land access, and we have a tool for managing stakeholders and stakeholder relations. So what's next? We've built this, we've got this nice proof of concept. It shows good value, I think. In future, I'd like to add real-time adaptation. I suspect that if we deployed this in anger, we'd find that the council would say, we broke it. We didn't inspect all these assets on this day and the schedule's all off. So we need to be able to react to asset inspections not happening when they're meant to. Or perhaps someone crashes into a bridge or something like that, right? There might actually be some assets inspected early. We can maybe do this with tie-in with Mott Inspect, one of those components that we talk about. This is a mobile app that allows inspectors to just kind of update data on the go on their phone. You can imagine a future where it'd be like being an Uber driver, right? It says, oh, you've inspected all these assets, but you've still got a couple of hours left in your workday. I reckon you could fit this one in. I bet they'd love that. It would also be good to work with different scheduling options. So this is all based around this kind of legally mandated 2-year schedule. We have a couple of projects like that. But it would be nice to start thinking about things like predictive maintenance. Sometimes you know which assets are likely to be going wrong soon, and you want to inspect all of those. But you don't actually have a legal requirement to do so. You just want to check everything's in good condition. So that's a slightly different problem, but would be solvable with a similar algorithm, I reckon. And then also, there's just other spatial reasoning we could integrate with this. Like, yeah, I mentioned land access, but things like, if you have to close a road, locating bridges on the same road and just checking you're doing everything, or aligning with other council works. So yeah, I think that's everything. Thanks for listening to my presentation, and let me know if you've got any questions.
Awesome. Any questions for Evan? Any questions, put your hands up, and we'll get a mic sent out. I can see there's 2 at the back here. Thank you, Daria.
Hello. Okay, thank you for the talk. I have a question. What are you using on the front end in the map and thing to visualize everything?
That's not my job. I think it might. I think we might use open layers, but I'm not entirely sure, to be honest.
Okay, thank you.
Daria, I think there's a gentleman there.
Hi, thanks very much for the talk. So, work in a similar sector in construction, and I know one of the real challenges with that and with infrastructure is quality of data availability. It's so often in spreadsheets or people's heads. How did you kind of gather the data required?
Well, yeah, there are a lot of spreadsheets involved in infrastructure. Some of it is just passing these spreadsheets, and other things are like nice, powerful tools like Mott Inspect. It kind of depends how far your client is along that digital transformation journey as to what tools you need and how much you need to, meet their requirements.
Thank you.
This gentleman here at the front.
Yeah, thanks again. What kind of features have you used to do this geospatial clustering? Is it just like GPS coordinates of the positions or anything else?
So we use the open source routing machine for the pairwise travel times. It's really nice and configurable. I think there would be some cool work to kind of look at maybe inspectors actually like to walk around their assets, but we're currently doing driving distances. But yeah, we're using that for the most part. But then when it comes to the scheduling, we have to have the distance is calculated based on both the date and the road distance. So we have to have kind of a multivariate problem there.
Okay.
Any more questions? Gentleman there, Daria, sorry.
Cheers, Evan, for the presentation. And a quick question, if it is your job. I
feel like I got a reputation now.
What kind of projects do you use the Mott tool internally, if you can disclose?
Kind of projects we use Mott for?
Yeah.
Mott geospatial, that map is like one of our biggest cells. We use that for big infrastructure projects and also kind of more small local client stuff like this with the City of Edinburgh Council. There's big linear infrastructure, working from MacDonald, I guess you can kind of imagine, and also more small scale stuff too.
So your colleagues are not using the tool for any other purposes?
Mott or the asset inspection?
It was more of a generic question for the internal tool. Mott specific or not, but yeah, internally, is it something that your colleagues come to you and, can I use this for my projects, or is it just purely infrastructure?
So MacDonald is an infrastructure company, so they're all infrastructure projects. But yeah, the asset inspection optimization, we've got a couple of projects in the pipeline, but this is kind of our proof of concept. We've essentially taken this, done a lot of sales on it, and now we're kind of starting to reap the benefits. The Mott platform, we try and deliver everything through that for the most part. It's our map, it's our main client software interface.
Okay,
Awesome.
thanks.
I think we're going to need to wrap up the questions there so that we stay on time. But Evan, thank you so much. That was a great presentation. Thank you.
Thanks.